Okay, guys, for section 3, it's about the scientific notation, per capita, and the proportions, okay? So let me assign the pages that we're going to cover today, okay, at the beginning of the class, okay? So if you have your book with you, let's turn to page 23, okay? All right, we're going to cover the discover part on page 23, okay? Yeah, the discover part on page 23. Then let's turn to page 24. We are going to do an entire page of 24, okay? Entire page 24 will be covered, okay? All right. Page 26. Entire page 26. Page 27. Entire page, please. Okay, so we will have a discover part. We'll also have a connect part. Okay, so entire page 27. All right, then let's turn to page 31. On page 31, let's do the entire page. Okay, so it consists of the discover part and also the first question from the connect part. So entire page 31. Alright, on page 32, let's do question 3 and question 5. Okay, on page 32, we do question 3 and question 5. Okay, let me see. Do I have more? Yeah, I believe that's it for section 3. Okay, section 3. Okay, so let's look at the material from section 3 at first. Okay, at first. So let's go back to page 23. On page 23, we're supposed to finish up this table, okay, this chart about powers of 10, okay. Well, for this table, okay, I'll just pick up some blank areas and we'll finish them, okay. The rest, you'll be able to finish them up by yourself, okay. All right, so this table tells us what? Tells us the American names of these numbers. They're in the standard number and also they're in the powers of 10. Okay, we'll do some of them. Okay, we'll do some of them. Well, maybe the whole thing. Okay, well, because there are not many blanks. Okay, so 1 in the standard number, how do we write it? How do we write number 1? Everybody knows this, right? It's so straightforward, right? Standard number 1 is written like this. Okay, and we know that as a power of 10 form, 1 can be written by what? 10 to the 0th power, right? 10 to the 0th power. Now the second line, number 10, we write it in this way, and then how about the power of 10 form? 10 to the what? First, right? 10 is equals 10 to the first, okay? And 100, we can consider it is 10 square, right? And how about this place? 1,000, right? Or 1,000, right? 1,000. So we can write 1,000. Okay? And then 1,000, we can see in a standard number form, it's 1, comma 3 zeros after the 1, right? So the power of 10, how do we write the power of 10? 10 to the what? Third. Okay, or 10 to the cube. Okay. Well, you can do these lines. Okay. Now let's look at this line. How to write 1 million in the standard form? How to write 1 million? After the 1, how many zeros should we write? 6. So 1, 0, 0, 0, 0. 6 zeros after the 1, right? After the 1. So in the power of 10 form, it is going to be what? 10 to the what? 10 to the 6, okay? So I require you guys to remember 1 million equals 10 to the 6 power. Or if we write it in a standard form, it has 6 zeros after the 1. Okay, I require you guys to remember this, okay, to remember this. Let me move this a little bit closer, okay. All right, now let's look at the next one that I want to pay attention, you guys to pay attention. How about 1 billion? How to write 1 billion? The previous one is 100 million, right? So 1 billion should be what? We should add 1 more zero after this number, right? So how to write 1 billion, guys? After 1 billion, how many zeros should after number 1 for 1 billion? 9. You are right. This is 1 billion, okay? And then 10 to the 9th power. So remember 1 billion, okay? Well, let's look at this line. We have 1 and the 12 zeros of this 1. What American name do we have for this number? 1 trillion. Yes, 1 trillion. So write 1 trillion. Okay, and then 1 trillion, remember it is 10 to the what? 12th power. Okay, yeah, so 1 trillion, that's 10 to the 12th power. And then how about here? Yeah, 1 quadrillion. Okay, because you may not know the number, but you see, oh, this is 100 quadrillion. So this one we can guess. It is what? 1 quadrillion. Okay, and then in the power of 10 form, it is what? 10 to the what? 10 to the 15, you're right. Okay, so for these special numbers, okay, like what is 1,000, which is 10 to the cube, 1 million, 10 to the 6, 1 billion, 10 to the 9th, 1 trillion, 10 to the 12th, and 1 quadrillion. Well, actually, this one you don't have to remember it. Okay, it's too big. Oh, this number is too big. We don't use it very often. No. So 10 to the 15. So you know these special ones. Okay. So that's good for this table, everybody. I'm not finishing up this entire table, but I hope you're able to finish up the entire table. What do you think? You are, right? You're able to do that, right? Okay. So this is the table on page 23. Any further questions? No? Can we move on? Okay. All right. Page 24. Scientific notation. Okay? Scientific notation. Have you heard about the scientific notation before? You do? Okay. Well, you may heard about it or you may not. It doesn't matter. Okay? We're going to study this together. Okay? Together. All right. So, procedure. This gray box, I'm going to ask a volunteer to read it, okay? Now I have the sign sheet, which is the roster, okay? So I know, I can call your name, so I will be able to know you, okay? So I'll start from the last, okay? Christine, can you read this box for us?
Just the box?
Yeah, just the box, yes.
Procedure for writing a scientific number in scientific notation. Move the decimal so that there is one non-zero number in front of the decimal point. Write this number times the corresponding power of 10.
Very good. Thanks. Okay. All right. So one number is called in a scientific notation, guys. This number, 1.2 times 10 to the 4th power. This number is in a scientific notation. Why? Because, guys, you see that to the left, okay? To the left of the decimal point, how many non-zero digits do we have? How many non-zero number do we have? Just one. Okay? So here, how to writing a number in scientific notation? First, we're going to move, where is the current decimal point? The place of the decimal point. It is here, right? So we're going to move the decimal point to the left for how many digits? Count. 1, 2, 3, and 4. Why we stop moving the decimal point? Because now there is only one non-zero number 1 in front of the decimal point, right? So now we can get a number 1.2, right? And then step 2, write this number 1.2 times by the corresponding power of 10, okay? So we're going to multiply by a power of 10. 10 to the what? Depends on how many digits we had already moved, right? So 4 digits. So that's why we get a 10 to the number 4's power. You guys? Alright, now let's practice, okay? Let's practice. Let's try questions 3 and 4 together. And I will let you do the question 1 and 2 by yourself in group, okay? So question 3. Write 92.96 million in scientific notation. $92.93 million. Remember just now I asked you guys to remember every 1 million equals 10 to the 6th power, right? So now we have 92.96 million. How can we rewrite this number without this word million? How? We should times 92.96 by 10 to the what? What is the power of 10 for 1 million? Remember just now? 10 to the 6. Very good. So this million equals 92.96 times 10 to the 6. Everybody agree with this? Now can we say this result is already in a scientific notation? Can we say it? Say that? Is this number in scientific notation?
Is there only supposed to be one number in front of the decimal?
Yes, you're right. There are 2 numbers, non-zero number before the decimal point, so this is not in the scientific notation. So what we do is we need to move the decimal point to the left for 1 more digits. Now guys, we still have to multiply a power of 10. Question for you. How about this index here? 7 or 5? Do we increase the 6 by 1 or decrease the 6 by 1? Increase, okay? So if we move the decimal point to the left for 1 digits, we increase the power of 10 by 1. Okay, why? Because from 92.96 to 9.296, this number becomes smaller. However, we need to make the product the same value as the old one. If this factor smaller, this factor must be bigger, okay? Yeah, bigger. Then the multiplication should balance, okay? The product of this part is balanced with this one. You guys, different opinion about this question? No? Yes or no? No? How about this number? Is this number in scientific notation? Yes or no? Is it in yes. So, we're good. What do you think? Challenging, right? Challenging. Okay. 0.86 million. Can you try it? I'll give you 1 minute to try it, and then we do it together. Write 0.86 million in scientific notation. Let me ask some of you guys answer the question for us. What do you get?
8.6 times 10 to the 5th power.
8.6 times 10 to the 5th power. Everybody agree with that? Great! Yes, you're right. 0.86 million can be written by 0.86 times 10 to the what? 6, right? However, this is not in scientific notation. We have to move the decimal point to the right for 1 digits. Then we're going to reduce the exponent by 1, right? So, 10 to the 5th. Wow, good. Yeah, correct. Okay, correct answer. So far, so good, everybody? Alright, so these questions, they're changing the question from, changing the number from a normal form, standard form to a scientific notation form, okay? However, how about we reverse, okay? How about a reverse action, okay? How can we change from scientific notation to standard notation? I'm going to ask a volunteer to read the procedure for us, okay? So what is the procedure? It is these 3 lines, okay? Morgan?
To change from scientific notation to standard notation, reverse the procedure. If the exponent on the power of 10 is positive, move your decimal point that many places to the right, adding zeros where necessary.
Okay, very good, okay, very good. So, we're moving decimal point, okay? So question 5 and 6. To standard notation. How? Move the decimal point to where? Left or right? Right. If the exponent or power of 10 is positive, we move the decimal point to the right for how many digits? 5 digits. Okay? So, we should have, okay, this product equals 6, 7, 8, 9. So only 3 digits, not enough. What do we do? Add extra zeros, right? Add zeros. Okay? So, answer is 678,900. How about question 6? Anyone tell me the answer? The gentleman.
2,456.78.
Okay, so 3,456.78. What's your name again? Okay, Damon, Sachs. Good, okay. Alright, everybody agree with this, the answers from these 2 problems? Okay. Alright, so these are the, rewrite numbers between scientific notation and standard notation. Now, let's look at how to compute, okay, do calculations with scientific notation, okay? So, this is actually question 7 and 8, okay? How to multiply numbers in scientific notation, how to divide the numbers in scientific notation. Before we do this, okay, let's go to an appendix, I believe. So, let me see, where is it? I think it's at the end of the book. If you have your book with you, let's go to page, guys, come to page 233. Let's turn to page 233. How to multiply and divide in scientific notation. There are 2 gray boxes. I'm going to ask a volunteer to read both of them for us. Okay? Alright, let me see whose turn. Irma?
Product rule for scientific notation. Multiply the decimal numbers, add the power of 10 together.
Example?
Example is 3.75 times 10 to the third power times 1.2 times 10 to the second power equals 3.75 times 1.2 times 10 to the third power times 10 to the second power equals 4.5 times 10 to the fifth power.
Okay.
Quotient rule for scientific notation. Divide the decimal numbers, subtract the powers of 10 from one another. Example, 2.4 times 10 to the ninth power divided by 1.2 times 10 to the sixth power equals 2.4 divided by 1.2 times 10 to the 9th power divided by 10 to the 6th power equals 2.0 times 10 to the 3rd power.
Okay, very good. Thanks. Okay, thanks. So, how do we do with multiplication, guys? Number times by number times what? Power by power. Okay, we all here. This answer is a 4.5, right? 4.5. So how do we get the 4.5? The product, right, from these two numbers. And then when we multiply the power of 10, how do we do with exponent, guys? Add them up. Okay, add up the 3 and the 2 give us a 5. Well, for division, we use number divided by number. However, for the power divided by power, how do we do with the power? Subtraction. Okay, subtract 9 by 6 give us what? A 3 as the power of 10. Guys, do you see the rule for both of the two cases, multiplication and division? Okay, so yeah, you don't have to compute this, okay? These are just the rules, okay? Now let's go back to page 24. Let's try both of these two questions, question 7 and question 8. Try question 7. You want to give it a try? Number by number. Power by power. Use your calculator, please. Compute 5.92 by 6.3 and let me know your results. What did you get? What's your 5.92 times 6.3?
37.296.
37 point what?
296.
296. I read whatever you tell me, okay? Alright, then times by 10 to the what? 14, multiplication, right? 14. Can we say this is the final line, final answer for the problem? Is this number in scientific notation? No. So in your homework assignments, okay, if you just multiply these two numbers, you type in this as your answer, very likely the system will mark you wrong because this final line, this is not a final line, okay? This is not in scientific notation. So how can we rewrite this in scientific notation, guys? Yeah, move the decimal point to the left for 1 digits, and then we increase the power by what? By what? 15. Okay, so this is the most accurate answer, okay? I would take this answer during your paper version exam. However, in the Ivy Learn, okay, if this number, they don't take it, try to retype it as what? 3 point what? Let's just keep two significant numbers, 3.7 times 10 to the 15. Why? Because there's also a rule talking about when we do multiplication, the answer will stay with what? The least significant figures. So this number has 3 significant figures, this number 4 2 significant figures. So eventually we have to make sure we only have 2 significant figures in our answer. Okay? Have you learned this before or no? In middle school or something? Okay. If not, that's fine. Because we also have the appendix, okay, from the book that you could check, okay, after class. Alright? Alright. On page 231, guys. Okay. Yeah, our textbook. Page 231. Okay. This section is about the significant figures and the rules for determining the number of significant figures. Okay. So with examples, with how to multiply and divide, okay? See, we have to keep our final answer in the least significant figures, numbers, okay? So this is the rule. So if you have time after class, you may also want to check page 231, okay? But this page is not the mandatory page. It's an optional page, okay? All right. So this is the multiplication, right? Have you tried the division yet? Let's do it. Division. What is the rule? Number divided by number, right? 1.9 divided by 4.62 times, what is the power? 10 to the 13, and then 10 to the what? Fourth power. Use of the calculator. Let me know. 1.9 divided by 4.62, what do you get? .41.
Yeah.
Okay, .41. You have already rounded it. Did you round it?
Yeah.
Okay, so .41, this is two significant figures, okay, that, yeah. And then times by 10 to the what?
7
7?
or 8.
13 minus 4 is what? 7? 9? Yeah, so 9. But can we see this is a final line for us? Yes or no? No, because this is not in scientific notation. So we have to move the decimal point to the right for 1 digit, and then how to deal with that power? Reduce by 1, okay? So, yeah. Move the decimal point to the right for digits, then we reduce the power of 10. Everybody?